Hi, welcome to this session about using Citrix ADC Nitro API for Day-2 operations. Let's start with a quick introduction. My name is Tytgat, I'm 38 years old. I am married, we have one lovely daughter who is about to go to school for the first time next week. Exciting times for her and obviously ourselves, besides the already strange circumstances due to COVID-19. I've been a Citrix ADC consultant for more than 10 years, so I basically live and breathe Citrix ADC. Old habits die hard, so don't judge me on saying Netscaler from time to time, as this is my first real virtual public speaking engagement. I am the co-founder of CoreLayer, a Belgian company focusing on Citrix ADC. Besides focusing on the ADC, we are also active in the more traditional networking and end-user computing space. CoreLayer is a Citrix solution advisor and a Citrix service provider. As a result, much of our consultancy activities have a service-oriented mindset, which is kind of the background story to everything we will discuss today. Especially for Citrix ADC, deployments don't always get the required attention from administrators, as it is still seen as a black box to many. Because of our focus on services and years of experience, we have developed some frameworks which should simplify operations on Citrix ADC. In our daily work, standardization is key, so all our consultants use these frameworks, allowing one consultant to step in for another one almost instantly for a customer they have never worked on. That said, time to have a look at the agenda for today. First of all, we are going to take a look at our CoreBox MSP appliance, which we use to provide managed services to our customers. Next, we are going to talk a bit about our Nitro SDK for .NET Core and our node backup service running on top of that SDK. After the Nitro SDK, we will look at how we can process logging messages from Citrix ADC and how it allows us to enhance metrics that we can pull out of it. Finally, we will explore CoreLogic, our configuration framework for ADC, while also circling back to logging to troubleshoot configuration issues. This is going to be a packed session, so let's get started. First topic of today is CoreBox. This appliance, based on the latest Ubuntu LTS, has a fully automated installer to generate templates for the most current hypervisors using HashiCorp Packer. By leveraging automation, we can provide a hardened appliance with cloud init support so that the actual network configuration can be adjusted automatically during the first boot of a new clone. Let's take a look at our templates for today. Okay, I have prepared two Packer configurations to build a generic Ubuntu template and a specific CoreBox template. The Packer configuration is basically a set of directives containing a builder block which tells Packer where it can deploy a virtual machine. It also informs the virtual machine on how it needs to boot, and after the boot process has finished, Cloud Init will kick in to perform the operating system installation. Once the operating system installation has finished, a set of provisioners will kick in to install extra files and software on the target machines. For example, for the Ubuntu master template, we copy our automation folder to the machine, and then we run some scripts which are in that folder. For example, upgrading all packages to the latest version, changing the interface names in the grub boot file, but also general hardening scripts and cleanup once we're done. If we take a look at the CoreBox master configuration, it is pretty much the same config, except for the fact that we run some specific CoreBox installation scripts to further install the necessary software to run a CoreBox appliance. For today's hypervisor, we will use Proxmox, as that is what we use in our data center, and as you can see, there are no templates at the moment. So as these builds take about 10 minutes to complete, let's get them started right away. I have opened up a connection to my installation server, and I have a bunch of scripts ready to deploy. If we take a look at the Packer configuration file, or scripts better, to install CoreBox, you'll see that it just calls Packer build with a variable file and then calling the CoreBox master template. So let's go ahead and run that script. Okay, it is calling Proxmox. It is starting a virtual machine. And if we take a look at the console of the virtual machine, you see that it's booting and it's calling Cloud Init to start installing. Okay, let's do the same on the second to start the installation of the Ubuntu master template. It will look exactly the same, but it will start a second virtual machine. There we go, it's performing the boot commands. And we're good to go. All right, for the time being, let's head back to the presentation. CoreBox comes with K3s, which is a lightweight Kubernetes distribution by Rancher Labs. Running on top of K3s, we run several applications to provide in our needs as a managed service provider. Currently, our two main applications involve the Nitro API for ADC, the first one being the metrics exporter from Citrix, the second one is our own backup service for Citrix ADC. We also run an instance of Elastic's Filebeat and Logstash so that we can provide for a syslog endpoint with batteries included. We parse the Citrix ADC logs, filter out messages which aren't relevant to us, and export the remaining messages to our log database. We also leverage logging to add metrics to the ones already provided by the metrics exporter. All metrics are in turn scraped by a Prometheus instance before sending them off to our central metrics store. Before we head off to the actual deployment of our templates, let's take a quick look at the next things we've planned for CoreBox, so our Packer builders have some time to complete. Two services which are currently in development are an automated controller for the Acme protocol, better known as the protocol on which Let's Encrypt is built, and a graphical interface to manage CoreLogic. We are also looking at providing locally running instances of Grafana, Elasticsearch, and Kibana. And last but not least, we are looking at opening up the source code of our Packer build definitions so that customers can verify what is installed on the appliances that we are deploying in their networks. Alright, let's get back to the demo and deploy our templates. Okay, now that our templates are ready, we can deploy some virtual machines using Terraform. We are going to deploy 3 virtual machines using the configuration, but first we have to set up Terraform in order to be able to do this. So first of all, we need to inform Terraform where it can find the required provider. In case of Proximus, the source is here and we need to specify a version as well. Next up, we need to tell Terraform on how to use that provider. So the Proxmox provider needs an API URL, it needs a username and a password. And since we are running a demo environment without a certificate, we set the insecure to false or true depending on what we need. But right now it will proceed with this. To the actual resources to be deployed, we have some variables that we define, username and a password to be passed on to Cloud Init. And then for the 3 nodes, we have an IP address, a gateway, and a name server to be defined. The nodes itself, well, pretty much the first one is a demo, let's say Kubernetes cluster to run some services on. It's based on the Ubuntu master templates. We assign some vCPUs and memory to the virtual machine, tell it on which VLAN it needs to connect. Then we configure Cloud Init so that it can insert a username and a password on boot. It will apply the network configuration. And then once the virtual machine has been deployed and is running, Terraform will be able to call some additional provisioners. So first things first, let's go to our provisioning server and we will see that I already have some Terraform scripts ready. So as I said in the beginning, we need to initialize Terraform. So if you take a look at the script, it's just calling Terraform init. Then we're going to do Terraform plan. And then finally, we are going to apply the configuration. So for Terraform init, it's easy. It will just initialize the backend, download the provider plugins, and we are ready to go. Then we do a Terraform plan. I do this just to get some output and to show you that we have 3 resources that will be configured: demo CoreBox, demo K3s, and demo rancher. And then we do Terraform apply, and the virtual machines will be created. As we can see in Proxmox, we now have 3 virtual machines which are being cloned. The provisioner for Proxmox is limited in that way that it needs to do a full clone of the virtual machine. So once the cloning process has been completed, Terraform will call the API again to start up those virtual machines. Let's go back to the console for a second. So you will see it's in constant communication with the Proxmox provider, and it is waiting on the virtual machines to start up. Once Terraform knows that the cloning process is complete, it will start and try to connect using the SSH protocol. Why is it doing that? Well, basically, if we look at our configuration file, we are calling some provisioning steps after the provisioning of the actual virtual machine. And in the case for our demo K3S system, we of course need to install K3S after boot up. For CoreBox, we pretty much do the same, but with the difference that we are calling the CoreBox master template instead of the normal Ubuntu one. So it's also calling the K3S one. And then for Rancher, it needs to do some additional steps. It will update the update server, so it gets a list of all the up-to-date packages. Then it will make sure that some packages are not available on the installed system. And then it will do some additional steps to install Rancher. Now, how is it doing that? Well, the provisioner are using the SSH protocol to connect to the virtual machine, and that is what you are seeing in the logging of the installation window. So once it's done, you will get a message from Terraform that the Terraform apply process has been completed, and we have now 3 virtual machines, one with our demo K3S, one with CoreBox, and one with Rancher. So let's connect to the consoles of those machines. Yes. CoreBox. Yes. And our Rancher machine. This gives Rancher enough time to boot up, so we can go ahead and open the Rancher application in our browser. If I forgot to mention, Rancher is basically a management platform for Kubernetes clusters. So, welcome to Rancher. We need to specify a password like this. Okay, agree to terms and conditions, set the base URL. Okay, and now we're good to go. We can add our clusters, so register an existing Kubernetes cluster, demo K3S, create. It will generate a YAML file that we can run on the K3S node. So we copy this, we go to demo K3S, sudo of the command. Let's go back a bit, sudo like this. And the file wasn't ready yet. There we go. That one is completed. Done. Let's do a quick refresh. Yes. Okay. Then we do the same for demo CoreBox. Create. Let's go to the CoreBox appliance. Run the same commands. Okay, we're done. And now we can see our clusters being ready and active. Now, for convenience, I will deploy the services on the K3S nodes immediately. So I have prepared a YAML file for the K3S server. Let's copy that one. Of course, we can do all this on the command line, but in this case, it's a bit faster to do it this way. So I copy paste the complete YAML file. I say import, and if all goes well, it should start deploying some workloads, which are basically a bunch of standard Nginx web servers having a blue, green, and red page. And then we have our own web services that we are running. Everything is running behind a CPX ingress controller. So we will see that we have all the services there and we are good to go. All right, CoreBox comes at a later time. So let's head back to the presentation. Next topic for today is our fresh implementation of the Nitro SDK for .NET Core. Worth mentioning first, the SDK is developed under an open source license so that it is easy for others to collaborate when there is missing functionality. Besides collaboration, it is also a way of giving back to the community. Of course, having this SDK was in our own interest as well, as we wanted to develop our own servicing application for Citrix ADC. So we needed to choose a language for development, and as the saying goes, stick with what you know best. In our case, the decision was made to use .NET. We had to take in mind one of our business requirements to be able to run applications on Linux and in containers to avoid additional license costs in using Microsoft Windows. This ruled out the existing Nitro SDK, which is based on the old .NET Framework version 2, and offered us the chance to start from scratch. Our SDK is built using async principles and does not require any external dependencies at this time, while we are also keeping in mind the best practices for .NET. Let's take a quick look at an actual application using our Nitro SDK. Our node backup service comes in several flavors, including cross-platform and platform-specific executables. More interesting to us is the availability to deploy the services as a container on CoreBox. So let's go ahead and do that. All right, we have our container image ready on Docker Hub. It's called CoreLayer / CoreLayer Citrix ADC Node Backup Service. So first of all, we need to prepare our Citrix ADC with a user account and a command policy to allow to create backups. So I've prepared the statements. We have a command policy which allows show system backup, create and remove backups from the system, show files specifically in the folder var _ ns_sysbackup folder. And then we will create a user with a username converge backup and password converge 2020 and assign the command policy to that user. So I'll go ahead and copy that. I'm already connected to my demo VPX instance, so I just run the commands, save config. Okay, now that's out of the way, we can go ahead and deploy our node backup file to our CoreBox appliance. So for the node backup service, we have to create a deployment with some parameters. So basically what we're doing is we are downloading the latest image on Docker Hub, and then in this case we set the configuration for our worker node through the environment variables. Now more specifically, you will see this is the IP address that we are using for our ADC, the username, the password. We are not using certificate validation on the VPX as we haven't installed the certificate just yet. And then we say that we want our backup configuration to start at midnight and with an interval of about 5 minutes. Backups will be stored on the file system in /var /CoreLayer /ADC /node backup. And then we are going to expose the node backup service to the cluster so that we can get metrics out of it later on. So let's go ahead. I'll copy the YAML file. I'll go to my Rancher, so make sure that I'm connected to demo CoreBox, default, import YAML. Just go ahead and import. So it will download the container image from Docker Hub, and it will already have created the service on the Kubernetes cluster. So if all goes well, we can take a look at the logs, and we will see that the application was able to start and test permissions on the ADC appliance. Configuration has been validated, so we are starting the service. And node backup is actually now counting down to the next backup interval, which is about 140 seconds, so about 2 minutes. If we take a look on the logging of our ADC, we will see that the user converge backup has logged on, created a system backup in the beginning, so that went well. And it looked up the latest backup, which is there, which was successfully. So now we can go on and go to the presentation again. Everything seems to be running as it should. Before we go on to the next topic, let's take a quick peek at the roadmap for our SDK. Currently, the only task-oriented operation is creating backups using Nitro API. Other task-oriented operations will be added later, such as updating the application flows regarding the ACME protocol for Let's Encrypt. We also aim to support Citrix ADM in the future and to provide IntelliSense support in a development environment. Alright, that wraps up the Nitro SDK. On to our next topic, logging. As I said earlier, we deploy FileBeat and Logstash to our CoreBox appliance in order to get logging out of Citrix ADC. FileBeat is a very lightweight application which can be configured as a syslog endpoint. All we have to do on Citrix ADC is add a syslog server to its auditing configuration. FileBeat in turn is sending all messages to Logstash, which is a heavier application capable of processing, parsing and filtering messages from all kinds of sources. As such, we configure the syslog server on the ADC to send all messages, including the debug level messages, and enable user-defined messages to be sent as well. Finally, Logstash is sending the processed messages to Elasticsearch so that we can easily look through the logging using Kibana. Let's go back to the demo and have a look at our deployment. Alright, let's take a look at the YAML file to deploy FileBeat and Logstash to CoreBox. FileBeat is pretty straightforward as we don't do a lot in the configuration. We only say that it's exposing syslog on port 8514, and in the end we are going to expose the internal port on UDP port 32001 in Kubernetes. First of all, we need to configure our ADC so it can send syslog messages to our FileBeat instance. So we configure the syslog actions on the VPX. There we go, save config, and then we are going back to the FileBeat file, select everything, go to Rancher, and then import the YAML file into our cluster. There we go. Now we will do the same for Logstash, but Logstash is a bigger configuration. So first of all, we are going to say in our pipeline that it will accept input from FileBeat. At the bottom, we will see that we output our messages into Elasticsearch. We actually have two separate indexes for CoreLogic related messages and then the system messages from ADC. And in between, we have the filter for our pipeline, which is basically parsing through a standard syslog message from the ADC and then do some filtering and some more actions on it. So let's go ahead, copy this into Rancher as well. There we go. Let's take a look at the logs in Rancher, and in the meantime we will take a look at the logging file on the ADC and to see if we can find a match. So we see that Converge Backup is still doing some things in the meantime, and if we go back to Rancher, Logstash should be starting up. There we go. So the pipeline is correctly configured right now, and we should start seeing messages from Citrix ADC. So to make sure that we trigger some of those, there we go again, we see that we get a parsed message from syslog. Now we can connect to our Kibana dashboard and start looking at the messages coming in. So let's open up our Kibana dashboard. The dashboard is loading. There we go. So we will see in our index management that we have a Converge 20,000 system index and a Converge 2020 CoreLogic index. And if we go and take a look at our system indexes, let's go to the last 15 minutes, we will see that we start getting hits. Cool, right? All right, back to the presentation. Okay, now that we have FileBeat and Logstash up and running, let's talk about enhancing metrics based on logging. As we've seen with the metrics exporter already, there are a ton of metrics available. However, some of our customers wanted to plan for security and upgrades in the future, and they were missing a vital piece of information. They wanted to know how many different SSL ciphers were used so that they could start narrowing down support for older ciphers and older TLS protocols. The information required is not available through any standard metric on ADC, but it is available in the logging. So we adjusted our pipeline in Logstash to parse the SSL handshake messages and create some additional metrics based on that data. For this, we developed a small application which is accepting the data through a HTTP endpoint. It parses the incoming data into the applicable metrics and exposes them back to Prometheus. So, we were talking about metrics. Time to deploy the Citrix Metrics exporter, an instance of Prometheus, and of course our own Cipher Metrics exporter. I have a YAML file ready, but before we talk about that one, let's take a look at the Logstash pipeline. As you can see, we filter out messages of type SSL handshake success and SSL handshake failures, and some of those fields are then sent to our Cipher Metrics service for further processing. So we get the customer field, the node name, the VIP, the SSL client version, and the Cipher version. Cool. Back to our YAML file to deploy the services. So first of all, we have our Cipher Metrics service, which is also on Docker Hub. We expose the service on port 5000. Then we deploy Prometheus, a standard Prometheus, which will scrape our Cipher Metrics exporter, the node backup service that we created earlier, and the Citrix Metrics exporter that is deployed as well. And then finally, we have the Citrix Metrics exporter service. Now, before we can deploy this YAML file, we need to go back to Rancher and add a secret, which is called nslogin, with the username nsroot and a password Converge 2020. Okay, now that we have that one, we can go ahead and deploy our metric services. All right, everything seems to be up and running. So we should start getting some metrics in Prometheus. Let's take a look at our targets first. So the Cipher Metrics service is up. Let's do a quick refresh and there we go. All the 3 services are available to Prometheus. So we should be seeing some metrics here. And as we can tell, there we are. So there's the metrics files that are coming from Citrix ADC, some general Prometheus related services. And let's trigger a SSL handshake by going to the web interface for the ADC. There we go. And now we should start seeing Cipher hits totals. Execute, and then we see that on our NSIP address we have used TLS 1.2 to connect to it. The cipher was AES 256 CBC SHA. Cool. This pretty much rounds up this demo. On to the last topic of the day, CoreLogic. CoreLogic is a framework we've built over the last 5 years together with my late colleague Roel Schrijbers. For a large redesign project involving thousands of content switching policies, we were looking at a way to clean up the mess of configuration that had grown organically over 5 years of production use. We analyzed the configured patterns and found out that we could reduce the required content switching policies to about 10 or 12, if we were able to have these policies accept some kind of dynamic parameters. Luckily for us, Citrix ADC has a set of functionalities providing exactly this kind of dynamic configuration: variables, policy extensions, string maps, and pattern sets. After many weeks of research, we came to the conclusion that variables weren't the right solution, as we had to set their values through a small detour in the configuration and packet engine. Policy extensions, on the other hand, added way too high delays in the processing, which eventually led us down to use string maps and pattern sets. Actually, there was an article in the official documentation describing a potential use case for string maps. We just took it to a whole other level. A typical ADC deployment looks like this. We have a content switching virtual server configured to send traffic for applications to their respective load balancing virtual server. We might also have a gateway attached to the content switch, and perhaps some of the load balancers are secured through AAA. In order to configure this, one would need to create a whole set of objects and policies and then make sure that one policy isn't conflicting with another one. After all, the highest priority wins. So we set out some business requirements for CoreLogic. CoreLogic had to be version independent, but also edition independent. So it has to run from standard edition all the way up to premium edition. It should rely heavily on standardization so that all consultants working on a configuration can quickly grasp all that is configured on the ADC. More important, it focuses on the application being configured. Although content switching and so on must be configured correctly, it is not the core reason why an administrator is configuring ADC. The application itself is the frontrunner, so the sooner we can talk about the actual application, the better. As a nice side effect, we saw a big performance increase, especially for large configurations, as there are less policies to be traversed on. There is a limited set of policies, which are dynamically controlled through a set of string maps, which are basically key value pairs. So, although the actual expressions in the policies are way more complex, they actually run faster because the lookups in the string map are based on the indexed keys. And last but not least, CoreLogic is again published as an open source framework, which can be used at no cost. The basic flow through CoreLogic pretty much boils down to this. We look up some keys in our content switching logic, then we evaluate some policies for our load balancing logic, and then apply some IP-based security rules to determine if a user has access to a specific resource. Let's take a look at a complete feature set of CoreLogic. All content switching policies are configured in an equal manner. We currently support TCP, UDP, HTTP, SSL, and SSL TCP virtual servers. If configured correctly, we can even have a SSL virtual server as a backup for an SSL bridging load balancing virtual server. We can modify traffic flow based on IP zones so that there is a different load balancing virtual server in place based on where you're coming from. We also have IP-based access controls for content switching and for load balancing virtual servers. You can look at them as layer 7 ACLs for HTTP traffic. For HTTP and SSL traffic, we have a set of special load balancing virtual servers which can modify traffic flows for specific requests. For example, we can have a redirect on a specific URL just by adding one entry to the right string map. In terms of content switching controls, we can direct traffic based on the destination port number for all layer 4 traffic types, such as TCP, SSL TCP, or UDP streams. For layer 7 traffic, such as HTTP and SSL, we have more options available. So let's take a look at an example. If you take a look at the following example, we can see how CoreLogic processes the request. Basically, the policies are configured to go from a very detailed request, which includes the FQDN and a full path, to a more generic one, the wildcarded domain. If we can find the appropriate key in one of the string maps, that policy will process the traffic and select the correct load balancer. Unfortunately, I cannot cover the complete feature set of CoreLogic in this session, so I'll need to have my demo do the talking in a moment. But before we can show what it can do, let's take a look at the current roadmap for CoreLogic. We are planning integration for the ACME protocol using DNS challenges instead of HTTP. And if you are running an advanced or premium edition of Citrix ADC, we are looking to generalize support for native OTP and self-service password reset through our current set of policies. On the right-hand side, we are looking at getting more data and metrics out of ADC in terms of CoreLogic functionality being used, in order to better support troubleshooting or business decisions by the customers. Enough talking, time for the final demo of the day. Okay, I've opened up our CoreLogic repository on GitHub, where you will see two important files, install.conf and createcss.conf. I already downloaded install.conf, so let's go ahead first and copy all these commands into our ADC, like so. Okay, clear the screen. Let's go back to our repository. The createcss.conf actually holds all the commands that you need to execute in order to create all the content switches for HTTP, SSL, TCP, and so on. The only thing that you need to do is do a find replace on tenant in uppercase, in lowercase, and with the IP address, and you're good to go. So remember, we deployed some applications using K3s, and because we don't have any config at the moment, these applications should still be non-responding. As you can see, connection refused. Okay, let's go ahead and go to our demo file. We are going to create our content switching virtual servers, copy the commands and deploy the content switches. And if we now refresh the page, we should get a page not found because we don't have any configuration at the moment, which is good. All right. Next up, we are going to deploy our applications. And remember, we deploy 3 applications. One is an IP address information service. Another one is a GUI for the API. And the third one is some color scheme. Now, you do as you always do. First, you create a backend server on the ADC. Then you create a service group with the correct connection settings. Next up, we create a non-addressable load balancing virtual server. And now comes the important part. We need to define 2 entries in a string map. The first string map is SMIP control, which needs to hold an entry with the name of the load balancer, stating if it's an allow list or a deny list. An allow list means you have to configure an IP address on that list in order to get access. A deny list does the opposite. So by default, it's a deny list with no entries on the list, so everybody gets access to that load balancing virtual server. Then we need to configure an entry in the SMCS control, which basically tells if you come in on this content switching virtual server from the internet with the FQDN API.CoreLayer.tools, I will send this traffic to the load balancer for vsdemo IP info. Same thing for CoreLayer.tools and same thing for colors.CoreLayer.tools going to the respective load balancer. Now have a look. For the vsdemo colors, I've set it to allow list for starters so that we can see what actually happens. I'm gonna copy this, execute, and now API should respond fine, like so, and colors should give me a connection reset instead of a page not found. And there you go, connection reset. Okay, now change the allow list into a deny list. Done, and we should be good to go. All right. Cool, let's clear the configuration and let's do something special. As you can see, I've prepared 4 statements here, which is saying red.CoreLayer.tools, if that traffic enters through the SSL content switch, do an HTTP 302 redirect to green.CoreLayer.tools. If you come in with green.corelayer.tools, go to blue.corelayer.tools. Blue will go to red/mybad, and red.corelayer.tools/mybad will go to the blocked load balancer. So why is this one different? Well, basically the first ones that we entered are all based on the FQDN, so we only look at the hostname of the request. This one will actually look at the hostname and the first path element. So let's go ahead and deploy those entries. Done. I have my debugger open, so I will go to red. And in that case, we should see a redirect to green, blue, and then back to red on a different path. And as you can see, red gives you a 302 found into green.corelayer.tools. Green.corelayer.tools gets a 302 found into blue. Blue gets a redirect into red. And red/mybad gives you a forbidden with a message in the browser. Okay, cool. Now, as a last example of this demo, we are going to request a certificate for colors.corelayer.tools. As you can see in the browser, let me hit one colors. Right now, we are using a wildcard certificate for this. So let's open up our Certbot application. Certbot will do a manual request to the staging server for Let's Encrypt. So at first, we are not going to do anything. Of course, I need to do this with sudo permissions. Like this. And go ahead. So we are not going to put any entry in it. Press enter, and you will see that verification will fail with a not found because there isn't any config for it. All right. Cool. Now, next is we're gonna rerun this script, clear. And now we are going to put the token in the string map, like so. And we are going to put the authorization token in there as well. So basically what we are doing right now is, if you come in on the HTTP load balancer from the internet using colors.corelayer.tools/.wellknown/acme challenge, I will point you to the Acme HTTP load balancer. And the Acme HTTP load balancer has a responder policy configured that will check if domain colors.corelayer.tools with the type HTTP and this token exists in the string map. And if it does, it will report this authorization token. Now, how can we check this? Well, quickly do a show run grep responder grep Acme, and we will see that we have a specific key that needs to be checked, like so. So we do a new grep, and we will see that it needs to be domain hostname, HTTP token, and then the third path element. So only the token is what we need. For the policy expression of the value, we can also check that it's domain HTTP token, and then it will return everything behind authorization equal signs and before the semicolon, which basically turns out to this. So let's copy, let's paste it in here, done, and then go back to our Certbot and press enter. And if all goes well, we should now be getting a certificate. Cool, that wraps up this demo. Let's head back to the presentation. As a final note, here are some interesting resources you might use if anything in this session sounds valuable to you. Thank you for joining me on this session. If you have any questions, we have a Q&A session on Friday, November the 6th at 10 a.m. PST. For exact timings, please visit the official website for Citrix Converge. See you there and have a nice day.